Hey, welcome to the second days of linear algebra with Python. In the first day, I have been showed you how to implement vectors in Python, and you can watch the previous video tutorials in this playlist. And today, I'm gonna show you how to implement matrix operations with Python. Uh, as you know, matrices are two-dimensional arrays used to represent linear transformation in systems of equation, and we can implement matrices of two-dimensional arrays in SciPy Linang modules, which provides various functions for matrix operations. In this day tutorial, I will cover essential matrix operations. The first one is matrix multiplication. Matrix multiplication is a fundamental operation in linear algebra. It basically combines rows and columns of two matrices to produce a new matrix. And the matrix multiplication is essential for solving systems of linear equations and for various transformation in computer graphics and physics. So this linear equation is very essential for computer graphics as well as physics. So this is a mathematical expressions of two-dimensional array or matrices. Basically, yeah, matrix is a two-dimensional array, but vectors is a one-dimensional array. I have already explained in the first video. Let's consider two matrices A and B. Let's consider two matrices A and B. And I will a matrix A is 1, 2. This is two-dimensional array, and 3, 4, and matrix B is 5, 6, and 7, 8. And I will perform the following operations. The first operation I'm going to perform is matrix multiplication. The matrix multiplication of A and B results in a new matrix. The product of two matrices is another new matrices. And how can we perform this in Python? First of all, we have to import libraries. Import NumPy as NP, and from then once we import the NumPy library, we can perform this using NumPy only. NumPy can support matrix multiplication. And now let's create two matrices. Matrix A is NumPy array 1, 2, and 3, 4. And the matrix B, which is 5, 6, and 7, 8. Now I have defined two matrices, matrix A and B, and I'm gonna multiply the two matrices and create a new matrix from the product of matrix A and B. This matrix multiplication. The product of matrix A and B is we can use NumPy, math, ML. This is very important function that NumPy provides to multiply two matrices, matrix A and B. Now let's see the product of the two matrices. Product. Oh, that's my mistake. Okay, that's correct one. Yeah, the product of the two matrices is another matrix. This is called matrix multiplication. So we can perform matrix multiplication with Python. And the second matrix operation is matrix determinant. The determinant of a square matrix represents the scaling factor of the linear transformation, which is defined by that matrix. If the determinant is 0, the matrix is singular, and its inverse doesn't exist. Determinant plays a crucial role in solving especially linear systems and calculating eigenvalues. So this determinant is very essential. So we can calculate determinants using SciPy library. SciPy library provides the most powerful function that gonna be used to calculate determinants from a square matrix. So in mathematical, we can perform a square matrix. The determinant of a square matrix A is calculated as the determinant of AD minus BC. This is the formula that used to calculate the determinant of matrix A, where A, B, C, and D are elements of matrix A. And so to do this, first of all, let's import libraries. Import NumPy as NumPy, and from SciPy, this is the most powerful library that used to perform a lot of mathematical computations, especially linear algebra, linear equations, and statistics. And we import Linang. This is one of the most important. Then once we import our module, let's define a matrix A. Define matrix A. The matrix A, let's say, is NumPy array 1, 2, and 3, 4. Now let's calculate, find the determinant of matrix A. So the determinant of A is okay. We can use Linang, which is the SciPy function. SciPy provides this function that used to find the determinant, and we use det function, and we pass that square matrix to this function. Okay, now we can see the result of this determinant of matrix A. Okay, that is -2 or -2. So this is based on the calculation of this. Let's do this manually. Let's say determinant of A is this from our matrix A. We can determine that the first element is A. So A 1 multiplied by the D is the last element. That is 4 minus, and B is this one, the second element in the first row. In the first row, that is 2 multiplied by C is the first element in the second row. That is 3. So this could be 1 multiplied by 4 is 4 minus 2, 6. That is -2. So instead of calculating manually, so we can just use this simple function to find determinant of matrix A. Okay. Another most important matrix operation is matrix inverse. So the matrix inverse of a square matrix is that undoes the linear transformation represented by that matrix. So if a matrix is non-singular, which means its determinant is non-zero, it has an inverse. So matrix inverses are crucial for solving linear systems and they are basically used in various algorithms and computations. So this is very essential, and you can perform this in Python. So the mathematical formulas of finding the inverse of matrix A is we can just divide 1 over determinant of, first of all, we have to find the determinant of matrix A, then multiplied by inversing the square matrix A multiplied. So once we find the determinant of that matrix and we inverse the matrix A, again we multiplied the inverse of that matrix determinant matrix A. Okay, let's do. First of all, let's import the libraries as usual. Import NumPy as NP. From SciPy, we import Linux. And now the next step is let's define matrix A. Matrix A is NumPy array 1, 2, 3, 4. Now let's find the inverse. Simply, without this mathematical notation, we can use a function from SciPy, Linang. We can find inverse of A using Linang dot inv. Then we pass that matrix into this, and we can find that the inverse of matrix A. Yeah, this is the inverse of, this is another matrix, but that matrix A is inversed. And when you inverse this, actually we can apply this. First of all, we have to just find the determinant of the matrix A, as we have calculated in the above. The determinant of matrix A is -2, and we just find that 1 over -2 based on the formulas, the mathematical of -2 multiplied by so we just inverse. D is the last element in the second rows of matrix A, that is 4. We just inverse that matrix, and minus B means the second element in the first row, minus B, and we can put that minus C and A. Minus C is the first element in the second row, -3, and A is 1. Let's multiply 1 over this means -1 over 2 multiplied by 4, that is -2, and -1 over 2 multiplied by -2, that is 1, and -1 over 2 multiplied by -3, that gives us positive 1.5, because 1 over 2 multiplied by 3 is 1.5. And the last one, -1 over 2 multiplied by 1 is -0.5. So this is the inverse of matrix A. So easily we can calculate the inverse of matrix A using this SciPy Python program. Okay, so we can do any matrices, matrices operation using Python with SciPy library and NumPy library. Don't forget to like, share, and subscribe, and watch the next video about linear algebra with SciPy.